Now let's see a special case of a quadrilateral called parallelogram. Now that we have discussed about square and rectangle, now comes the important definition called a parallelogram derived from a quadrilateral. What is a parallelogram? Parallelogram. The word parallelogram itself says that a closed figure formed by parallel lines. So let's see the special case in terms of a quadrilateral. So here the word parallelogram itself has the word parallel, which means the four straight lines which are formed by forming a closed region, that is the line 1, the line 2 and the line 3, which is parallel to this. The condition is that all four straight lines which are joined together to form a quadrilateral must be parallel. The pair must be parallel, is how we understand parallelogram. The third line which I take must be parallel to the first line, and the fourth line which I take, the condition is that that fourth line must be parallel to the line 2. That means if I take out here, then this must be parallel to this, is how we understand the line 1 parallel to line 3 and line 2 parallel to line 4. All the two pairs are parallel, and thus such a line formed with a pair of parallel lines forming a closed region is called a quadrilateral, given by special name parallelogram, is how we understand parallelogram. So here I understand parallelogram to be in the shape of a rectangle, a sleeping rectangle or a slanting rectangle. In this case, ABCD is a parallelogram such that this is parallel to this, and because they are parallel, also I have noticed that the opposite sides are also equal. Let's see that in brief. Observations I make here are that in quadrilateral ABCD, my line segment AB is parallel to line segment DC, and my line segment AD is parallel to line segment BC. Is parallel to BC. Therefore, opposite sides are parallel to each other. Similarly, I notice that when two pairs of opposite lines are parallel, their lengths are equal. That is, this length equals this and this length equals this. Also, I notice the line segment AB is equal to line segment DC, and my line segment AD is equal to the line segment BC. So therefore, in this case, we see that such a quadrilateral ABCD, which satisfies these two properties, is called a parallelogram. That's how we understand the quadrilateral as a special case with a parallelogram. Parallelogram. Let's define parallelogram in words. A quadrilateral in which opposite sides are parallel, and of course when they are parallel they must be equal. Of course, equal in length. Is called a parallelogram. Is how we understand the parallelogram. Parallelogram, a quadrilateral in which opposite sides are parallel and the opposite sides are equal in length, is called a parallelogram. A quadrilateral with a special case of opposite sides parallel and equal is given by name parallelogram. Now let's see the angle sum property in a quadrilateral. Angle sum is today's session. As we have seen in the case of a triangle with three sides, obviously there are three angles in a triangle. The angle sum property in a triangle was defined to be that sum of three angles in a triangle equals 180 degrees. What would be the sum of all the angles in a quadrilateral is the biggest question out here. So let's investigate the sum of all the four angles in a quadrilateral. What would be the possible value of when I take all the four angles and add up? So let's take a quadrilateral ABCD. So here I have A, B, C, D, which is a four-sided closed figure quadrilateral. This is angle A, this is angle B, this is angle C, and this is angle D. So here I have four angles, angle A, angle B, angle C, and angle D. Let's sum up to see the property. So what does angle sum property define? Angle sum property. Angle sum property says my angle A plus my second angle B plus my third angle C plus my fourth angle D, which is called sum of all the four angles of a quadrilateral, which is equal to 360 degrees, is how I define angle sum property. Sum of all the four angles in a quadrilateral must equal 360. Sum of all three angles in a triangle equals 180, and sum of all four angles in a quadrilateral equals 360. Is how we define the angle sum property. Let's communicate this in words. learning outcome here is that sum of all angles in a quadrilateral is 360. That's how I define the angle sum property. Sum of all angles in a quadrilateral inside the quadrilateral must be equal to 360 degrees is what we understand as the angle sum property. Now that we have discussed about the angle sum property, let's try to apply angle sum property in real life. So let's see how we can solve the problems in finding angles of a quadrilateral using the angle sum property. Applications in solving. So let's see one of the application of angle sum property in solving the math problems. For example, I have a quadrilateral where this is ABCD, a quadrilateral ABCD, in which this angle is 70 degrees, this is 80 degrees, (65 degrees). This is X. So I know three of the angles, but I want to find the fourth angle. Then my angle sum property is more significant in case of such situations. For example, for this given problem where I need to find X, let's see how we can find X using angle sum property. Clearly we know that the given conditions are that angle A is given to be 70 degrees and my angle B is given to be 80 degrees. My angle C is given to be 65 and my angle D is given to be X, and we need to find the angle D, that is the value of X. So let's see how we can find the angle D using angle sum property. Now clearly from angle sum property, for quadrilateral ABCD, we have angle A plus angle B plus angle C plus angle D, all sum equals 360 degrees. So angle sum property for a quadrilateral where my sum equals 360 is what we have seen in the previous session. Now that we know each of the angles, let's substitute in the given angle sum property. So here for angle A, I substitute the value of 70 as given in the problem. So here I get 70 and then my angle B, which is 80 degrees, and my angle C, which is 65 degrees, and my angle D, which is X degrees, which I need to find, is all equal to 360. degrees. Therefore, sum of all this equals 360. Now my target is to find the value of this x. So let's see how we can find x from this equation. Let me add all this 3. 70 plus 80 is 150. 150 plus 65 is 215 degrees is what we get. Plus x degrees equals 360 degrees is what we get when it is further simplified. Now because I want to find x, I put x on the left side and this is taken to the right, so that this reduces to x degrees equals 360 minus 215 degrees. Next, now 360 minus 215 is 145 is what we see. Therefore, my x is this, is what I get in terms of angle sum property. So my angle sum property, when simplified through each of the angles substituted, I get my x, that is my fourth angle, which is 145 degrees. So given the three angles in a quadrilateral ABCD, I can find the fourth or the unknown angle using angle sum property. So my learning outcome here is that the angles of a quadrilateral can be found using angle sum property. In this case, my unknown angle, angle D, is found to be 145 degrees using angle sum property. Angle sum property helps us in finding the unknown angles of the quadrilateral 145 degrees in this example problem.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.